So today we will continue seeing quadratic equations. We will see the second method for solving quadratic equations, that it will be completing the perfect square trinomial. Of course, if we are completing a perfect square trinomial, we know that a perfect square trinomial comes from having a binomial squared. X plus y squared equals x squared plus 2xy plus y squared. So remember, that's the structure of a perfect square trinomial. Remember, a quadratic equation, normally it's a trinomial because we have the quadratic term, the linear term, and the independent term, a, b, and c equals 0. And we can have normally also, instead of having a number here, we have a number 1, and it will be x squared plus bx plus c equals 0. It says here, sometimes it looks like it has the structure of a perfect square trinomial, but something is missing. Like we won't have the complete perfect square trinomial. That's why we were calling this topic completing the perfect square trinomial. So we will need to complete it to become a real perfect square trinomial. And here we have again the structure of a perfect square trinomial. So let's think a little bit with this example. This example, of course, it's a perfect square trinomial. We have x squared plus 6x plus 9. Why it's a perfect square trinomial? The first one has a square root that it's x. The third one has a square root that it's 3. 3 times 2 times x, it's going to be 6x. So this one, it's a perfect square trinomial. If we see when a has a value of 1, that we don't have a number here, and we have the square term and the linear term, we can obtain the c term. Why? Because if this one is exactly 1, we can apply this little rule. The letter c, the independent term, because this one is 1, it will be always b divided by 2, all of it squared. Let's see if it applies. If we don't know this specific term, we can do 6 divided by 2, it's 3, all of it squared. We can know that the answer of the third term is going to be plus 9. So that way, when we have the square term and the linear term, we are able to complete the perfect square trinomial. So we will see how to apply it on the next examples. So imagine we have something like this: x squared minus 4x minus 21 equals to 0. In this case, we can move the 21 because we don't need it there. The only terms that we need is the x squared and the linear term. And what's the rule? Remember, we need to put the middle one divided by 2, all of it squared. And for not affecting the original equation, we need to put them on the two sides of the equation. Why? Because we are putting a new number there, so we cannot put only a number in one side of the equation because we will be modifying the original one. We need to put it on both sides. What will happen here? Of course, it's going to be x squared minus 4x plus 4. Why it's going to be plus 4? 4 divided by 2, it's 2. 2 squared is 4. Equals, it's going to be 21 plus 4. Because it's going to be, again, 4 divided by 2, it's 2. 2 squared, it's 4. That means this one we can factorize it as a perfect square trinomial. X minus 2, all of it squared, equals to 25. Then it's going to be x minus 2. How do I isolate a square power? We will isolate it with a square root. So after that, it's going to be x equals the square root of 25 plus 2. What happens here? Remember, when I have a square root, we have two possibilities. Because the square root of 25 can be positive 5, but also the square root of 25 can be negative 5. Why? Because 5 times 5 it's 25, minus 5 times minus 5 it's also 25, plus 2 and plus 2. That means x equals to 7, and also x equals to minus 3. So we have the two answers for x equals 7, x equals minus 3. Remember those numbers, x equals 7, x equals minus 3, will tell us specifically where it crosses the x-axis. And remember, in this case, the c term on the original equation that was minus 21, it's going to be where it crosses the y-axis. That means our equation will have a form like this or something like this. So remember, it will be always the same structure. We will need to complete the perfect square trinomial in order to be able to solve the exercise. Let's see another example. So in the next exercise, we have something like this. So remember, first of all, we need to eliminate all the parentheses and so to have the structure of ax squared plus bx plus c, or x squared plus bx plus c. So in this case, we have a multiplication between two binomials. So it's going to be x squared plus 2x. Then it's going to be minus x minus 2. That it will be the multiplication of these two. Then it's going to be minus 13x plus 26 equals to 24. So in this case, we change all the terms to the left, so it equals 0. So it's going to be x squared, it will be x squared. Then 2x minus x minus 13x, it's going to be minus 12x. And then the numbers 26 minus 2, it's 24. The 24 goes to the other side as a minus 24. 24 minus 24, it's 0. So here it's going to be plus 0. What does that mean in this case? A has a value of 1, B has a value of minus 12, and C has a value of 0. So what can we do on this one? We need to complete the perfect square trinomial. How do we complete it? Remember, it's going to be plus the middle term divided by 2, all of it squared. If we put it on one side of the equation, we need to put it on the other member of the equation. So it's going to be x squared minus 12x plus, and here it's going to be 12 divided by 2, it's 6, squared is going to be 36, equals to 36 also. What can we do on the left side? We can do x minus 6, all of it squared, equals to 36. What happens next? We can change the square power with a square root equals to the square root of 36. So in this case, it's going to be x equals the square root of 36 plus 6. And remember, we have two possibilities. X equals 6 plus 6, and x equals minus 6 plus 6. Why plus 6 and minus 6? Remember, the square root of 36 can be plus 6. 6 times 6 is 36. Or it can be minus 6. Minus 6 times minus 6, it's also 36. That means x equals to 0. And I'm sorry, I'm doing the other one. This x equals to 12. And the other one is the one that x equals to 0. What does that mean? Remember, that it will cross the x-axis on 12 and on 0, because c on the original one equals to 0. That means it will cross the y-axis on 0, and we will have something like this maybe. So remember, all the exercises are going to be kind of similar. We need to complete the perfect square trinomial. We will need to send the square power as a square root. Remember, the square root has a positive and a negative answer. And in that way, we will be able to solve for x. Sometimes we will have two answers. Sometimes we can have one answer. And remember, if they ask you to do the verification process, I'm not doing it in this topic. We saw it on the last video. But if they asking you to do the verification process, we need to use these values of x on the original equation, this one that we have here, and we need to have something equalized to another stuff in the other side of the equation. So let's see another example. So in the third example, we have something like this. So remember, first of all, we need to eliminate, in this case, the fractions in order to have the structure of a trinomial. So we need to multiply by the least common multiple. In this case, if we factorize this one, it's going to be 2x plus 1, 2x minus 1. That means all the equation, I need to multiply it by 2x plus 1 and 2x minus 1 in order to eliminate the fractions. So the first part is going to be 9. That multiplies, I'm missing the 2x plus 1 minus x plus 3. I'm missing the 2x minus 1. And finally, the minus 3, I'm not missing anything because I have the 2 on the denominator, so it's going to be only multiplied by 1. So it's going to be 18x plus 9 minus, and let's see, 2x squared minus x plus 6x minus 3 equals to minus 3. If we continue doing it, remember the minus sign will change the sign of everything inside the parentheses. 2x squared plus x minus 6x plus 3, and we can change the other minus 3 to this side, equals to 0. That means we will have minus 2x squared. In the case of the x's, 18 plus 1, it's 19, minus 6, it's going to be 13x, and then it's going to be 9 plus 3 is 12, plus 3 is 15, plus 15 equals to 0. So in this case, we have the negative minus 2x squared, so we can change the sign of every term to have the x squared as a positive one. So I change them maybe from the left to the right side of the equation to have the 2 as a positive one. We will have here a little problem that we haven't on exercise 1 and on exercise 2. What happens here? The value of the number that it's with the x squared term, it's 2, it's not 1. And we only know how to work when a has a value of 1. So what can we do in order for that number to be exactly 1? We can divide all the equation by 2. If I divide all the equation by 2, I will get x squared minus 13 halves of x minus 15 halves equals to 0. So after we do that division, it will be a normal exercise. Remember, x squared minus 13 halves of x. Of course, we will have something here. Squared equals 15 halves plus the same stuff here squared. What happens in this case? Remember, to obtain c, it's the middle term divided by 2, all of it squared. If I divide 13 halves divided by 2, it's going to be 13 quarters, because 13 multiplied by 1 it's 13, 2 times 2 it's 4. That means here we will have 13 quarters, all of it squared, 13 quarters, all of it squared. So what will happen here is going to be x squared minus 13 halves of x plus 169 divided by 16 equals 15 halves plus 169 divided by 16. What happens next? Of course, this one, it's a perfect square trinomial because we do it. So it's going to be x minus 13 quarters, all of it squared. And on the other side, we need to have 16s to be possible to add them. So the second one, it's already 16. The first one, we need to multiply it by 8. So 15 times 8, 120. So it's going to be x minus 13 quarters, all of it squared, equals 289 divided by 16. What happens next? Remember, x minus 13 quarters, we can change the square power as a square root. So it's going to be x equals the square root of 289 over 16 plus 13 quarters. So we will have two possibilities. One that it will be a positive one that it's going to be a negative one. So let's see. The square root of 289, it's going to be 17. So we have 17 quarters. The square root of 16 is 4 plus 13 quarters. And we will have also x equals minus 17 quarters plus 13 quarters. Why plus and minus? Remember, we have the two possibilities that can be a square root, a positive sign or a negative sign, because plus times plus it's positive, minus times minus it's positive. So this one is going to be 17 and 13. It's going to be 30 over 4. That is going to be 15 halves. So x equals 15 halves. And on the other side, it's going to be x equals minus 4 over 4. X equals exactly to minus 1. So we have the two values of x. We have that x equals minus 1 and x equals 15 over 2. That is going to be 7.5. So it will cross exactly here. And remember, we need the value of c. But we are not going to use this value of c, because this value of c is like a modified value of c. We will use this value of c. C has a value of 15, positive. That means exactly we'll cross. I'm sorry, not this one. Because this one, we use this one. We use this one. It will cross specifically on minus 15. So it's going to be something like this. So remember, the important stuff is to solve the actual x. Know where it crosses the x-axis, maybe where it crosses the y-axis, but the most important part is to solve the actual exercise. If they ask you to do the verification process, of course, we need to use these two values of x. We need to substitute it here on the original equation to see that we have something equalized to something that is exactly the same. And in that way, we will be able to check that our answers are the correct ones. So let's see another example. So in this last exercise, we have something like this. So first of all, remember, we need to complete the perfect square trinomial. So in this case, we need to eliminate the parentheses first. So it's going to be 6x minus 2 minus 3x squared minus multiplied by minus is plus x minus 5x plus 20 equals 2x minus 6. If we change all of them to the right to become positive, the x squared, it's going to be 3x squared. That goes to the right, that's why it becomes a positive one. Then the x, it's going to be 6 plus 1, it's 7, minus 5, it's 2 positive, goes to the other side as a 2 negative, plus 2, it's going to be 0x. I will put a 0x, we will like eliminate it on the next step. So we have do the x. What about the numbers? Minus 2 and 20, it's plus 18, goes to the other side as a minus 18. Minus 6, it's going to be minus 24. That means our equation is going to be 3x squared minus 24 equals to 0. So what happens here? We don't have a middle term in this case because a has a value of 3, b has a value of 0, and c has a value of minus 24. So what happens here on this one specifically? On this one specifically, we have that the number that we have is different than 1. So the first stuff to do the perfect square trinomial completion, we need to have a 1 here. So we can divide everything by 3. And it's going to be 3x squared. I'm sorry, I didn't divide by 3. It's going to be x squared minus 8 equals 0. So in this case, of course, maybe we can do it like in a single step because we can like isolate the x squared. But if we think about how to complete it, of course, it will stay exactly the same, but it's going to be x squared equals 8. And remember the rule to complete the perfect square trinomial, it's the b term divided by 2, all of it squared. The b term, all of it divided by 2, all of it squared. It's going to be 0, so it will stay exactly the same. X squared equals 8. That means x equals exactly to the square root of 8. Of course, we can apply our knowledge about radicals. X equals exactly to 2 cubed, and we can take out a 2. Remember, our answers from a root, we have 2 of them, one of them positive, one of them negative. So it's going to be 2 the square root of 2, or it can be also minus 2 the square root of 2. Why we have a positive and a negative? Again, remember, when we solve an exercise of a radical, positive times positive gives me positive, minus times minus gives me positive also. That's why we can use this one. Of course, we know that the answer of x and the answer of x are specific points where it crosses the x-axis. So we need to know like the decimal number of this one and this one to know exactly where it will passes. It's between 2 and 3. It's going to be between 2 and 3. So it's going to be something like here and something like here. Then we have that it crosses the y-axis when c equals minus 24. That is going to be like on the bottom part, and it's going to be something like this. So with that information, we are finishing the topic, completing the perfect square trinomial. I know that it's a long process, but it will be always having the a number 1, then we will be dividing the b term, the middle one, divided by 2 all of it squared, put it on the two sides of the equation, and isolating the variable. So that will be it for today's topic. See you on the next video where we see another method that it will be an easier one to solve quadratic equations.